Hi friends, myself Dr. Sonali and welcome to my channel called MedRecall. Today we are going to learn about types of blood vessels. Before moving to types of blood vessels, let's see what is today's quote. It is life is full of beauty, notice it. Okay. If you are creating your mindset as a positive, then you will see the beauty of life. Then let's move on to the type of blood vessels. First, we are going to learn about arteries. So, what are arteries? Arteries are the conducting and distributing vessels. They carry blood away from the heart. Most carry oxygenated blood except pulmonary artery and umbilical arteries. It means pulmonary artery and umbilical arteries, they carry deoxygenated blood. Okay, deoxygenated blood. And all the other arteries, which are major arteries, they carry oxygenated blood. There are two types of arteries. The first one will be elastic arteries. They are conducting. Okay, the example is aorta, pulmonary trunk. Then what are its special features? So it has thick tunica media with elastic fibers that helps to maintain continuous blood flow. It has a pulse dampening function, and also elastic arteries have a vasa vasorum in the tunica adventitia. So look at this basic structure of wall of blood vessel. This is lumen. Okay, it is lumen part. Then there is internal elastic lamina. Okay, it has intima. Okay, which is towards the lumen. After intima, there is media, tunica media. Okay, this part is tunica media. And then the last one, the third part is adventitia. Okay, so tunica media has elastic fibers also, and it also has muscles. There is another type of arteries which is called as muscular arteries. They are distributing. The main function of elastic artery was conducting, and the main function of muscular arteries is distributing. Example, medium sized arteries like radial artery, femoral artery, coronary arteries, etc. Tunica media here is rich in smooth muscle and it distributes blood to organs. It has internal and external elastic lamina. तो याद रखना, तो remember that muscular artery, mainly the size of muscular artery is medium, whereas elastic arteries are bigger one, larger. And the muscles are more in tunica media of muscular arteries as compared to that of elastic arteries. Then what is arteriole? Arterioles are the resistance vessels. They are the chief regulators of systemic blood pressure. It is an MCQ point. So arterioles are chief regulators of systemic blood pressure. They have narrow lumen. Firstly, the elastic arteries have larger lumen as compared to muscular arteries, and muscular arteries have larger lumen as compared to arterioles. So arterioles will be the vessels which have narrowest lumen, 1 to 2 layers of smooth muscles, and there is very little elastic tissue. Elastic tissue is very little in arterioles. Okay, that's why they don't recoil, but they act as resistant vessels. They regulate total peripheral resistance. So it is an MCQ point that they regulate total peripheral resistance. Precapillary arterioles supplying skin, muscle and kidney. So the main function of arterioles, which are precapillary, the function is to supply skin, muscle and kidney. Now let's compare what we learned: elastic artery, muscular artery and arterioles. Okay. Now see, in elastic artery there is tunica, intima, then media and then externa. The size of tunica media is larger in elastic artery and there is more elastic tissue. Elastic artery is having more elastic tissue as compared to muscular artery. In muscular artery, there is less connective tissue, more muscles, more smooth muscles in tunica media. And after that, in arteriole, tunica media carries less muscles, less smooth muscles, and also the lumen is narrower. Okay, here in arteriole, the lumen is narrower. You can see the lumen in here. The arteriole lumen is narrower, okay, than muscular artery, and elastic artery is having more wider lumen. So elastic artery is having wider lumen as compared to muscular artery and then arteriole. Diameter of these blood vessels decrease from elastic artery to arterioles. Okay, first diagram which is showing slide of blood vessels. You can appreciate tunica intima here, which is towards the lumen. After that, tunica media is wide enough, so it may be elastic artery. Then tunica adventitia, and then you can see vasa vasorum here. Then the second one, you can see the cross section. There is tunica media here. This is tunica media. This is lumen showing blood. Then tunica adventitia is last layer. Then the third one, this is arteriole. You can appreciate lumen containing blood, then tunica media, and then tunica adventitia. Lumen will be narrower in arteriole. Now let's see what are capillaries. So capillaries are exchange vessels. Okay, they are exchange vessels. These are the smallest and thinnest blood vessels. Capillaries are smaller and thinner than they are smaller and thinner than arterioles also. Okay, the site of exchange for gases, nutrients, hormones and waste. It is very important point. Then there are three types of capillaries. The first one is continuous capillaries, second one is fenestrated capillaries, and the third one is sinusoidal capillaries. I will show you diagram, then you can understand it better. So this one is continuous. Okay, continuous. Here you can see there is no gap in between the endothelium cells. These are endothelial cells. Okay, so there is no gap, so it is called as continuous capillaries. And this yellow portion is basement membrane of the endothelial cells. Then comes fenestrated. Fenestrated have some gaps, that is junctions in between the cells. Then comes sinusoidal. Sinusoidal has major gaps. Sinusoids, voids are there. Okay, these are fenestrations. You can see in continuous capillaries, most commonly you can see continuous type of capillaries in our system. They are found in muscles, skin, lungs and central nervous system. They have tight junctions. Remember, tight junctions are present in continuous capillaries. They are continuous endothelium and they are blood-brain barrier type, very selective. Okay, so they are very selective and they are part of blood-brain barrier. Then comes fenestrated capillaries. They have pores. Okay, these have pores, that is small holes are there. They are found in kidney, glomerulus, endocrine glands and intestine. They are highly permeable. Okay, you can see there is fenestrations. These are holes. Okay, so they are highly permeable because they can exchange substances through those pores. But in continuous types of cells, in continuous types of capillaries, there are no pores. Okay, there are tight junctions. They are only selectively permeable. Then what is sinusoidal capillaries? Sinusoidal capillaries are discontinuous. They are most permeable. They have large gaps, incomplete basement membrane. They are found in liver, spleen and bone marrow. They allow passage of cells. So sinusoidal are having more number of gaps and more large gaps. Therefore, they are more permeable than the other types of capillaries. Okay, so according to permeability, the type of capillaries which is more permeable, which is the most permeable, is sinusoidal, then fenestrated and then continuous. Okay, let's see what are veins. So veins are the capacitance vessels. They are called capacitance vessels because at resting phase they store 60 to 70% of blood. Okay, and they are very stretchable. They have thin type, they are thin and they are flexible. So they are thin and they are very stretchy. They carry blood towards the heart. It contains deoxygenated blood except pulmonary veins and umbilical veins. Remember these things. People often get confused that veins carry deoxygenated blood, but exception is there, which is pulmonary vein and umbilical vein, which carry oxygenated blood. In spite of they are, irrespective of they are called veins, but they carry oxygenated blood. They are thin walled than arteries. They are thinner and larger lumen. The basic difference between vein and artery is that veins have larger lumen and thin wall. There is presence of walls in veins, but in arteries there are no walls. Okay, it is important factor that will differentiate veins from arteries, especially in limbs, to prevent backflow. And also it is important to remember that not all veins have walls. It is specifically seen in veins of limbs to prevent backflow. It acts as blood reservoir, contain about 70% of blood at any time. Therefore, it is called as capacitance vessels. Example, great saphenous, jugular vein, hepatic portal vein. Compare the structure of vein and artery. Because it is very flexible and stretchy, and it has narrow lumen. Whereas arteries are not stretchy. It has a constant lumen. Okay, artery. It has a wider lumen. Then you can see there is endothelium in vein, then nerve also there. This thing, then tunica externa and vesa vasorum and endothelium. All those structurally these are same. All those substances which are smooth muscles present in tunica mid, the basic pattern which is the layers, that is tunica media, tunica intima, adventitia, all those are same in both arteries and veins. But the special feature of vein and artery, you can differentiate it on the basis of types of lumen. You can often get vein, the lumen will be narrower and compressed. You can see the vein compressed, whereas the artery is not compressed. Okay, the lumen of artery is firm, whereas in vein it is compressed. Now let's see what is venule. Venule is similar to arteriole. As there is artery, we have other thing which is veins. We have arteriole, so we have venules. Okay, they are collection vessels. These are thin walled, smaller vessels receiving blood from capillaries. There are two types: post capillary venules and muscular venules. Post capillary venules are a major site of leukocyte migration, that is diapedesis. This is MCQ point. Remember that venules are the major site of leukocyte migration, that is for the diapedesis. So diapedesis occurs at venules. Okay, then there is muscular venule. Muscular venule have 1 to 2 layers of smooth muscles. Okay, You can see in venule there is tunica intima, then media and externa. As I said before, the basic structure of blood vessels, that is tunica intima, media, externa, and whatever they contain, that is smooth muscle in elastic fibers, all those things are common to all these types of blood vessels, but only the composition will change. Composition will change and their property will change, and their actions, their functions are also different. And this one is the last thing to compare. So first you saw aorta, then arteries. According to the size, they are getting smaller from aorta to arteries. They carry oxygenated blood towards the body from heart. Okay. After aorta, then come arteries. After arteries, there are arterioles. Then capillaries. Okay. Then let's see what about the deoxygenated blood. Then vena cava, largest vein. After that, veins. Then venules, and then capillaries. Okay, capillaries are the tiniest, are the smallest thing. Okay, these are cross sectional areas, and this is velocity of blood. If you see velocity of blood flow, it is more in aorta and vena cava, then it decreases in capillaries. Okay, it is least in capillaries, so velocity will be least in capillaries. This was an overview about type of blood vessels. So watch it till the end and like it, share with your friends. Thank you for watching. Don't forget to subscribe my channel. Bye.